Statistics has many different chapters. So like we did the statistics at the start, which was the average and the histograms, and then we did the linear regression with the correlation, and now we're doing time series. But the time series is only 2 lessons. The one we did yesterday and the one we're going to do today. And then we're already on to a new chapter after that, probability. You know this word, yeah? Yeah. What's that? Tony's causing trouble? No? Okay. Now we have everybody. Great. We'll start. So, okay. So last time you remember we had a look at the time series where x could be sales. So we said x at time t is equal to a constant plus a trend plus, what was the last part? A seasonal part. So for example, you would have something like this. Yeah. And do you remember what a moving average was? So a moving average is where you take, like for example, let's say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And what is the period here? 4. Yeah, 4. So the moving average is where you take 1, 2, 3, 4 and get the average. And then you take the next 4. Well, the next move along one. 1, 2, 3, 4. Then you get the average. And then you go 1, 2, 3, 4. And you get the average. Remember this, the moving average. So what we're going to have yes? Oh no, questions, yeah? Questions? Are you sure? Don't be shy. I like questions. Right, so the next one we're going to have a look at is similar, but we call it the multiplicative model. It's a bit of a time delay. So in this one, it's nearly the same, except the trend is actually a curve shape like this. It's actually not a straight line, but it's curving upwards. And we still have the seasonal part like this. So it could be going like that. So it's nearly the same. The only difference is the trend is now a curve instead of a straight line. So we say, if we call this x, x is equal to a constant multiplied by, some kind of trend part, and then multiplied by some kind of seasonal part. Yeah, it's actually a multiply now. That's the only difference. So it's nearly the same except multiplying instead of adding. So the difference there is that the graph can get very big very quickly. So it could go something like this. That's ugly. We'll do a real one in a moment. So this is a multiplicative model. Yeah. Okay, have you got that? Yeah. So last time I tried to make up some numbers, but like I said, I'm much better at making up numbers at 1 a.m. instead of 9 a.m. So I'll use the numbers in the worksheet as an example. So if we hand these out, we'll have a look at the example in number 1. So just take one and pass it along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does everybody have one? Yeah? Okay, so let's have a look at this now. Back to whispering again. I'm sure you were talking about maths. So much no in that. Right, discard. Okay, so you have a look. What is this data representing? What is this example in number 1? What have we got here? It's temperature for different years. So let me just put this into a table and then we can make the graph. What do you notice about the temperature? It's increasing, isn't it? Yeah. Oops. Okay. So we'll just put here year, and we start at 2000, and 2001, 2002, 2003, 2004, 2005, 2006. How far do I need to go? 11. Okay. And the temperature? Oh my goodness. I forgot how to count. Right. 11. And the temperature is, what is it, 15.3? 15 point... No, 3. 15.4, 15.7, and 7 again.
15.8.
Yeah.
16.1.
Same. 0.2.
0.5.
Same. Okay. So let's have a look at this time series now. Be gone. Right. Insert chart. Now, you can't really see it on the graph, but you will see it's going to be more of a smooth increase rather than a straight line, but we'll try anyways. Okay, I want this one, and question 1, and this is year, and then this is temperature in Celsius. You can't really see it on this graph. If I maybe try to put in now, it's impossible to see because it's so small, but you can see the trend line there. Now, I know it looks like a line, but if you were able to zoom out, you could see that, in fact, it's not a line, but it's actually curving upwards instead. But we can't see it here because the numbers are a little too small. But anyways, it is curving up then. Okay, so what I want you to do is just roughly draw this in your notebook. So this is what it looks like for this example. So this is part A, the plot. Need to make this a little bit smaller. Oh, actually, I've got a full screen mode, don't I? There's a full screen somewhere. Full screen. That's better. Okay. I'm just trying to make the curvy part seem a bit more noticeable. No. Oh well. Okay, nearly got that. So if you were looking at this, let me move this to the side so I can have the numbers here as well. Shrink this a bit, shrink this a bit, and then we can shrink it a bit more. Okay, part B is what is the period. So I don't know if you can see, but can you tell me what the period is from that?
3.
What do we think? No, I don't think so. Not 3. I don't think so. Or maybe it is 3. Sorry. Is it? I was thinking maybe it was 2, but let's have a look. So, we need to pick a... Yeah, actually, if we start here, this is clear. If we start here. So this is 1, this is 2, this is 3, yeah. But not this one. So it is 3 then. So the period is 3. So the answer for part B is 3 years. Okay. Can you just calculate the first and the second moving average, and then I'll do the rest. So just practice giving me the first and the second moving average. First and second, yeah, just to practice. So, does anyone have the first?
Yes.
What did you get?
15.2.
15.2? Correct. And now the next one? 15.33. Okay. Now, I don't want this many decimal points, so actually, let me make it 1 decimal point. Wait, that's no decimal points. Hang on. I want 1 decimal point. Let's try again. Round, average. There, 1 decimal point. Okay. Right, so you can write these down. Let me go back to full screen. So these are all the moving averages. Yeah? I guess I did 2 decimal places here. Now the reason these are a little bit different is because maybe when I did it last night I had more decimal places, so don't worry about it. I'll change this to 1 decimal place. Okay, have you got those? Yeah? Yes? Yes? Can I delete this graph? I need to make space, so I can delete this? Yes? Okay. Now, remember yesterday we had a look at how the moving average changes. So in this example here, how does the moving average change? It increases by 0.1, and then here is 0.2, and then here is 0.1, isn't it? This is different to yesterday's class. How was the moving average changing yesterday? You were adding the same number. So yesterday the sales were moving average was increasing by 100. But here it's not like that because it's not like yesterday's class. So does anybody have any ideas? If you think about yesterday and you think about what we're doing today, in this case I don't look at the difference. I don't do this minus this. What do you think I might have to do instead?
Average.
Not average, no? What do you think? Well, if you remember back here, what's the difference between today and yesterday's model? Today's model, the change is a multiplication, whereas yesterday you were adding. So it's like the difference between AP and GP. So here, maybe I should look at if this is a GP divided 15.3 divided by 15.2. So this is 1 point, okay, that's too many decimal places, let's make it 4. 1.0066 increase multiplied. Now, it's not great, but it's not too bad. You can kind of see that most of the time it's 1.006. Now the reason it's quite inaccurate is because here I did 1 decimal place. Maybe I should have done 2 or more. So if I change this to 2, it's a little bit better. In the exam, it doesn't really matter as long as you do 4 significant figures. So I'll do 1 more for fun. Okay, now that's much more accurate. So can you see, with using 3 decimal places, what's happening each time to the moving average? It's increasing by 1.0085 about. So if I round this off to 3 decimal places, these should all be 9s now. Yeah, mostly. About 8.5, 8.5. So the moving average is getting multiplied each time by about 1.0085, something like this. Instead of yesterday where we were adding by 100 each time. So what's happening, it's a bit like x is a constant and then we have this multiplication term, 1.0085 to a power multiplied by the season. That it's almost like it's a GP, whereas yesterday, I think what was happening, we were adding 100 each year or each month or something, so it was almost like you had plus 100n in the formula. Okay, so that is the answer to what is the trend. The trend is an increase by 1.0085. So you would say, is it yearly increase by a factor of 1.0085. And what is this as a percent? What percentage is this? Is this 8%? No? Yeah, this is a 0.85% increase per annum, per year. Do you know this PA? Means per annum, each year. Whereas yesterday we had something like an increase. Yesterday it was something like plus 100 euros per annum. This one is a multiplication, or a percentage if you want. Okay, so can you write that down? That's actually the answer to part D. What is the trend? It's an increase of 0.85% a year. Got that? Yeah. Can I go back to the spreadsheet? Yeah. Yeah, what do you need to calculate? That? The 1.009. This number? Yeah, it's this divide this. Yeah. So, which letter is this like? If this was like GP, this is like OR. And yesterday when we did the model, this was like, what, D? Yeah. Okay. Next, we want to predict what the temperature will be in 2012.
State the model.
Oh, sorry, state the model. Actually, that's what I kind of did up here. This is, do you see this answer here? This is the model. That's actually the answer for E. That the temperature is a constant multiplied by this 1.0085 part multiplied by some seasonal adjustment.
It tends to be like exponential.
Yeah, this will be exponential, correct, yeah. Yeah. Now, this seasonal number here, what type of number will this be? Like, will it be a number that's very big, very small, nearly zero? I mean, what do you imagine the types of numbers, values here? What do you think? Would this be nearly zero? What do you think? What do you think? The seasonal part. See, nearly zero? Not nearly zero? What do you think?
Would be more or less than 2 times.
Could be. Maybe. Maybe not. No? Well, I tell you, it shouldn't be nearly zero, because if this was nearly zero, what would happen to the temperature? It'd be nearly zero. So what's happening is, this seasonal part is nearly, what do you think?
1.
Nearly 1. When you have a situation like, oh, my graph is gone. When you have a situation where the point is above the trend, what do you think the seasonal value is in those situations? When the point is above the trend? Well, it's bigger than 1. And then if the point fell under the trend, smaller than 1. And if the point was on the trend, then this is now 1. And the constant, what do you think the constant is on the graph? Well, it's like the number at the start. Yeah, 15 or whatever. Yeah? Get the idea? Yeah. So anyways, that's what I mean by what's the model. This is the model here. Next part. Predict for 2012. Okay. So we want to know what will it be for 2012. Okay, so we don't know the temperature. That's what we want. And we don't know the moving average, but we could know the moving average, because we know that the moving average, yeah, very good. The moving average here should be what? Go ahead, Malik.
1.0.
Yeah, multiplied by 16.4. So that should be it there. And then we just do 2 decimal or how many decimal places was I doing? 3. So 3 decimal places would be its number. And this is x. Now, do you have enough information to find the x? You do, because what should the average of these numbers be? It should be 16.531. So I want you to try and get the x for me now. You have enough information to get the x. I should get it too.
16.592.
Let's check 2, yeah. Okay, let me write it down. So, we have, what was the first in the moving average? 16.5 plus x over 3 should equal
16.5.
okay, so 16.531 times 3 minus 16.5 minus 16.5. So I got my prediction for 2012 for the temperature is 16.593 degrees, or if you want 16.6 degrees. I deleted the question on the residuals for this lesson because the syllabus says that students don't need to calculate the residuals, but I think, like I said yesterday, I don't really believe what they say sometimes. So, if you want to calculate the residuals, it's just the difference between the trend and the data. But I don't think they shouldn't ask you that in the exam. Okay, so what we'll do, you have question 2 there. So I'll let you try number 2, and then I wasn't thinking about doing a tutorial. Well, I can do a small tutorial if you had questions, but I don't feel like there was anything difficult enough for a tutorial. Did people have questions on something? No. So I'll let you work on this for 10 minutes, and then we'll have the next lesson instead of the tutorial.